Hi, I'm Kate, and this is my video for physics extra credit. So this is about the biggest rope swing in the world. And the first thing that we do is you figure out the speed at the bottom. We're assuming that the rope over here, that the rope is 150 feet long, which is 45.72 meters. And the mass on the rope is 60 kilograms, and then that the stretch is 40%, which I found on a rope website. That'll become relevant later. So first, over here, we figure out the speed at the bottom using the energy principle. Delta K equals delta U, plus delta U equals energy. And we manipulate those to find a formula for velocity, and then we plug in our gravity times, this is, so in my system you start at 0, and it's kind of upside down, so you start at 0 and you go to like positive 45 is like the position. So the velocity at the end is, at the bottom is 29.95. That's going to be the biggest velocity because that's when you're going the fastest. So the tension in an ideal rope, the tension force is mass times gravity, because it's got to be opposite gravity to keep you from falling. So the tension force is 60 times gravity, which is 588.6. Then for the third part, the speed and tension at 30 degrees, we use this diagram to find the height at 30 degrees, and then this formula from before, and found that the velocity would be 26 meters per second. The stretch at the bottom is, there we are, 40, so 40% is how much the rope stretches, and that times the length of the unstretched rope is the same as L naught minus L, which is the stretch in the rope. So if we use those calculations, we find that the stretch is 18.29, which, is L naught minus L. So the force of the spring, which is equal to the tension force, which we found over here, is, or rather, right here, is 588.6, and you divide that by this stretch, and you get 32.19. And then you find this stretch. To find the stretch at 30 degrees, you use this. This is the kissing circle formula. Is equal to that's the force is equal to our spring force of our ideal rope. 45.72 plus S is this, and you find this, and then I use some fancy Pythagorean theorem work right here to get that the stretch at 30 degrees is 17.678. And next is my VPython part. Thanks. Bye.